Hello everyone, welcome to this session on data types in C++. In this lecture, we will understand what data types are, why are they important, and the different categories of data types available in C++. So what is data type? Before writing any program, we need to know what kind of data we are working with. A data type tells the compiler what types of value a variable will store. It also determines how much memory should be allocated, the range of values that can be stored, and the operations that can be performed on that data. For example, an integer stores whole numbers while double stores decimal values. Choosing the correct data type helps in writing efficient and reliable programs. So let's begin with the most basic category called primitive data types. These are built-in data types provided by C++. They include int, float, double, char, bool, and void. Almost every C++ program uses one or more of these primitive data types. So first we start with int. The int data type is used to store whole numbers such as 10, 100, minus 25, something like this. It does not store decimal values. Typically, an integer occupies 4 bytes of memory and can represent a very large range of positive and negative numbers. One important point to remember is integer division. For example, if we divide 7 by 2 using integer, the result is 3 instead of 3.5 because the fractional part is discarded here. Next is integer sizes. So C++ provides different integer types depending on the amount of memory and the range required. Short uses less memory and is suitable for smaller numbers. Int is most commonly used integer type. Long can store much larger values. As programmers, we should always select a type that is appropriate for the expected range of values, balancing memory usage and application requirements. The next data type is float and double. When our data contains decimal values, we use float and double. A float usually occupies 4 bytes and provides around 7 digits of precision. A double occupies 8 bytes and provides approximately 15 digits of precision. Because of its higher accuracy, double is generally preferred in most applications. Notice that float literals require the suffix f, whereas double value do not. So next is char data type. It stores a single character enclosed in single quotation marks. Internally, every character is represented using its ASCII code. For example, the character A has an ASCII value of 65. This relationship between character and numbers is useful in many programming applications. Next is bool data type. This stores only two possible values, either true or false. It plays very important role in decision making and looping statements. Internally, true is represented as 1 and false as 0. Whenever we use conditions in an if statement or while loop, the result is always a Boolean value. Next data type is void. It represents the absence of a value. It is commonly used as a return type of functions that performs a task but do not return any result. For example, a function that simply displays a message on a screen can have return type of void. Next comes the type modifiers. Now let's look at type modifiers. These keywords modify the size or range of basic data types, allowing programmers to better match the data requirements of the applications. So here comes signed and unsigned. By default, integers are signed, meaning they can store both positive and negative numbers. If we know that a variable will never store negative values, we can declare it as unsigned. This doubles the positive range that can be stored using the same amount of memory. However, programmers must be careful because subtracting from 0 is an unsigned integer can produce unexpected results here. The next is size of operator. This operator helps us determine the amount of memory occupied by a data type or variable. Since the exact size may vary across different computer systems, using size of is the safest way to check memory requirements during program execution. So far we discussed built-in data types. Now let's move on to derived data types, which are created for existing data types. The most common derived data types are arrays, pointers, and references. So starting with arrays, array stores multiple values of same data type in a single variable. Each element is accessed using an index starting from 0. Arrays make programs more organized because we don't need separate variables for storing similar data such as mark of multiple students. Next is pointers. A pointer is a variable that stores the memory address of another variable. The address operator AND is used to obtain the address, while dereference operator asterisk is used to access the value stored in that address. Pointers are one of the most powerful features of C++ and are widely used in dynamic memory allocation and efficient data structures. And next comes the references. This is another name for an existing variable. Unlike pointers, references must be initialized when they are declared and cannot refer to another variable later. Any change made through the reference directly affects the original value, since both refers to the same memory location. Now, C++ also allows programmers to create their own data types, and that is known as user-defined data types. Commonly used user-defined data types are structures and enumerations. So starting with the structures, struct is a keyword here. This groups multiple related variables into a single unit. For example, if we want to store information about a student such as name, roll number, marks, we can combine all these fields into one structure. This improves code organization and readability. Next comes enumeration. The keyword is enum. This defines a variable that can take only a fixed set of named values. Instead of remembering numerical values, we use meaningful names like low, medium, high. Next, the auto keyword here. The auto keyword allows the compiler to automatically determine the data type based on the assigned values. For example, assigning 10 creates an integer, while assigning 3.14 creates a double. Next comes the type conversion. Sometimes it becomes necessary to convert one data type to another. So C++ supports two kinds of conversion. One is implicit and the next one is explicit. Implicit conversion happens automatically, where there is no risk of losing information. Explicit conversion is also called as typecasting. This is performed by the programmers when data need to be converted manually, even if some information may be lost. So here are some common beginner mistakes. Beginners often make a few common mistakes while working with the data types. Integer division removes the decimal part unexpectedly. Using a data type that is too small can cause overflow, producing incorrect results. Another common mistake is using variables before assigning them a value, which results in unpredictable outputs. Therefore, always initialize variables and choose the correct data types. Here comes a quick reference. This table summarizes the commonly used data types, their approximate memory sizes, and the example values. So to conclude, to summarize, today we learned about primitive, derived, and user-defined data types in C++. We also discussed type modifiers, automatic type detection, type conversion, and common programming mistakes. Selecting the appropriate data type improves program efficiency, conserves memory, and makes the programs easier to understand and maintain. So thank you for watching this session. In the next lecture, we will build upon these concepts and begin writing more practical C++ programs using variables, operators, and expressions. Thank you.